Hi guys, today we're going to take a short break from graphing quadratic functions, and we're just going to go ahead practice taking a quadratic function in standard form and then writing it in vertex form. How? By completing the square. Cool, fantastic. Okay, so let's do this. So a gentle reminder, what does vertex form look like? So a quadratic function is set to be in vertex form if it looks like this. So f of x or y equals a times the square of x minus h plus k, where the vertex is given by hk. So what's after the minus and what is the constant term? Fantastic. Okay, so let's do this. So where am I? Okay, so let me go ahead and rewrite the function just in case I need to tag it up. I can still see what the original problem looked like. Okay, the first thing I want to do is fix it so the leading coefficient is 1. Okay, fix so it's 1. Okay, why? It would just save us a lot of headache. Okay, we're gonna go ahead group the variable terms, and then the constant term we'll put it to the end. Okay, so we have f of x equals, and the only way we're gonna fix it so the leading coefficient is 1 is if we factor out a 3, regardless if it goes into 6 or not. It will be nice if it does, but if it doesn't, who cares? We want it to be 1. Okay, so we're gonna go ahead factor out a 3. Okay, so 3x squared divided by 3, look at that, x squared. Okay, the number in front of x squared is 1. Fantastic. Keep going. 6x divided by 3 is 2x, and then we're gonna put a little gap because we want to complete the square, so we're gonna add something, but we can't just ignore that minus 2. So let me go ahead close it, and then we'll bring down the rest of the problem. So to complete the square, it's a 4-step process. So 1, we're going to identify b, 2, multiply it by half, 3, square the result, and then 4, add the result. So the value of b, where am I? So the value of b is the coefficient of the x term. So the value of b is 2. So to complete the square, let's go ahead identify b, 2, multiply it by 1/2, or some books will say, or some instructors will say, divide by 2, same difference. So to complete the square is a 4-step process. 1, identify b, 2, multiply it by 1/2, 3, square the result, and then 4, add the result. Okay, so we're gonna add 1. Okay, so let's go ahead add 1, but then we have to remove it right away. Okay, if you don't subtract it, then you're changing the polynomial. Okay, so in this case, we want to have a perfect square trinomial. This minus 1 is in my way, so we're gonna have to take it outside the grouping symbol. But I want to point out is this: on paper we put +1, but we didn't really add 1. Notice how this 1 is inside our grouping symbol, so we added 1 times 3 or 3. Okay, so we're gonna have to remove this minus 1. How? By distributing that 3. Okay, so if we added an undercover 3, we're gonna have to remove an undercover 3. Okay, so let's go ahead bring this down. So we have f of x equals 3 times the first 3 terms, x squared plus 2x plus 1, and the minus 1 has to go. So again, we didn't really subtract 1, we subtracted 1 times 3 or 3. Okay, 1 times 3 is 3, so let's go ahead put minus 3, and then we'll bring down the rest of the problem. Okay, cool. So let's go ahead factor and then confirm that we do have a perfect square. So we have f of x is equal to 3 times x times something, x, sorry, I'm at a loss for words. So we have a trinomial, leading coefficient is 1. Let's go ahead throw down parentheses, focus on getting the first term. Product of the first term should give us x. To complete the binomial factors, we want factors of c that add up to b, factors of 1 that add up to 2, and that will be 1 and itself. And if you have a moment, if the numbers are not coming to you, so the secret ingredient or the secret weapon is just look at your work. Whatever half of b is, that's always going to go in the parentheses. It's not a trick. It comes from math, but we have no time to dive into that. Okay, bringing down the rest of the problem, -3 minus 2 will give us -5. Let's go ahead and use exponents for repeated factors. So we have f of x equals 3 times the square of x plus 1 minus 5. So after all that math, I forget what the objective was. So it says write in vertex form. Nailed it. How did we do it? We did it by completing the square. You know, we added something so we can have a perfect square. And then we're asked to write the vertex. Okay, so a gentle reminder, function is said to be in vertex form if it looks like this. Let me go ahead and write down our answer. Cool. So unfortunately, we don't have x minus the number, but that's a very easy fix. Okay, so let's go ahead and force the subtraction. Okay, subtraction is the same as adding the opposite. So subtracting -1 is the same as adding 1. But now that now that we have a minus, it's with confidence I'm going to see that the value of h is whatever follows the subtraction sign. So in this case, h is -1, and the constant term is going to give us k. So we are asked to identify the vertex and the equation of the axis of symmetry. So the vertex is given by the ordered pair hk. So in this case, the vertex is -1, -5. The axis of symmetry, it just depends how you see things. I don't see anything unless I actually see it. So I'm just going to go ahead and do like a quick sketch. Well, I lie. I'm just going to locate the axis. I'm going to locate the vertex. So the vertex is given by -1, -5. So we're going to go 1 unit to the left and then 5 units down. Okay, this is how we go quickly. Okay, I'm going to go ahead label the coordinates of the vertex for my peace of mind. Pretend you can read that. That reads -1, -5. The axis of symmetry is the vertical line that goes through the vertex. So then the question is, what would be this equation? So this equation requires that the value of x is always -1. You can't see it because it got crossed out. So this equation requires that the value of x always equals -1. Okay, so the equation is that. So axis of symmetry is given by x equals -1. And the question is, how come I didn't complete the sketch? Because I didn't have to. I mean, you can if you want. You know, it's a parabola that goes up because the leading coefficient is positive. Okay, fantastic. So we were asked to write the function in vertex form by completing the square. We were asked to identify the vertex. We were asked to identify the axis of symmetry. So we're good. Thanks, guys.